I think machine learning is pretty epic, as I'm sure most of the other instructors and most of you do. Um, but there are limits, and like it's a big kind of source of debate about like what are the limits of machine learning, like how far can it go? Can you get to like general artificial intelligence with just machine learning? That is kind of a source of debate. So that's what I'm going to be talking about. And as an explanation of my sort of like journey to working in AI, I am from Northern Ireland. I did my undergraduate in England though, and then I actually worked as a teacher for 4 years. And then I worked for a politician who is in the bottom left corner. And then I did a master's in policy and data science. And I actually didn't expect to go into work in AI. I was planning to go and work in like policy because, you know, I'd obviously worked in politics before. But yeah, I ended up, I now work for a company called Cognino AI as an AI engineer. And so like some of the work I do at Cognino AI is sort of related to the topic of this lecture. So this is, you know, what I'm saying here is probably slightly like there are debates around some of these things. So everything I say is not like 100% empirically true. So feel free to challenge me, you know, instructors, students, on what I'm saying. But the way I see it is that traditionally there have been two of the major types of artificial intelligence have been symbolic AI and machine learning or empirical machine learning. And the way I think about it is that symbolic AI is really when you build AI that like learns knowledge from experts. So you get expert knowledge and you like input it into an AI. An example of that would be like Deep Blue, which was IBM's AI that defeated Garry Kasparov, the chess player. And that was like lots of expert chess players kind of contributed their knowledge to Deep Blue. So it was like an expert system, like symbolic AI. And symbolic AI was quite dominant in the field until the 1990s. And since the 1990s, machine learning has become more important in AI. And DeepMind created AlphaGo, which defeated Lee Sedol, the Go player, in like a few years ago. So and the difference between symbolic AI and machine learning is that in machine learning, basically we learn from examples. So you give the AI lots of examples and you tell it like this is an example of a dog, this is an example of a cat, and it learns the representations of a dog and of a cat. And so that's obviously what you have been doing during this course is basically machine learning. So these are kind of two different forms of AI, like symbolic AI and machine learning. But at the moment, machine learning is much more dominant. And so like the progress that has been made has been, I think, really surprising to lots of people. I think lots of people didn't expect there to be like machine learning to be as like powerful as it has been. So for example, GPT-3, which some of you may have heard of, is a really famous machine learning model, which was created by OpenAI. And it's huge and it can write essays. And it's an absolute, like it's a ginormous machine learning model. And there's actually an even bigger one, which was released by the Beijing Academy of Artificial Intelligence, I think around 6 months ago. And it's actually like significantly bigger than GPT-3 and sort of, I believe, based on GPT-3, but it can do all kinds of crazy stuff. Like you can give it text and it'll produce a photorealistic image of that text, or you can give it an image and it creates text. So yeah, these are like pretty gnarly machine learning models basically. And they obviously are like massively impressive to us. Also AlphaFold 2, which is another DeepMind model, has been like, you know, it demonstrates that machine learning can like make massive strides in science and can do things that previously we might not have thought would be like possible with AI. But so basically there's been a huge amount of progress and it's like so impressive. But there are some people who also have pointed out that there are limitations to machine learning. So for example, Francois Chollet, he works at Google, and he actually helped develop Keras, which we have been using over the last week for some of the like neural networks we've been creating. And he argues that quite a lot of like machine learning researchers have an interest in exaggerating the success of machine learning. And he thinks there's actually a lot that machine learning can't achieve. Timnit Gebru as well has been quite sort of prominent, especially since she left Google. And she argues that, especially in large language models, like large NLP models, she argues that because some of these NLP, I mean, all of these NLP models, they don't actually understand the prediction they're making. Because she argues that we haven't, like, these models don't actually understand fully like natural language. So she says that's very, very dangerous, because a model, for example, could make a prediction which is sexist or racist, but the model itself doesn't understand like why it's making that prediction. In contrast, say, to like a human who, even if they are doing something that is like making a prediction which is wrong, they have some sort of understanding of that of that decision. So then there is much more of like a transparency and a process by which you can like change that person or change the decision. Judea Pearl also he created an algorithm called Bayesian networks, and so he's quite like a famous computer scientist, and he basically argues that like machine learning has no understanding of like causation. So it doesn't understand like, and he thinks that's like a really big problem, because he thinks like fundamentally the way like the brain works is causal, and he thinks we can never get to general artificial intelligence unless we have unless we inject some sort of like causality into machine learning. So he's quite rude about like machine learning. He doesn't think it's like as amazing as everyone thinks. So like one example of this, and I think this does link to what Thomas was saying actually, is that say if you were trying to predict the classes of these two people, like say a computer vision model is trying to predict the classes of these two people, like does anyone know who these two people might be, like what their roles are? I don't know, I guess. You can put it in the chat.
Teacher and student.
Yep. Yeah, nice. Cool. Yeah, exactly. Like student and teacher. So it is possible that a machine learning model could predict that this is student and teacher. But the question is like, does a machine learning model actually know what a student is? Like how deep is their like a machine learning model, how deep is their understanding of what like a student is? It's probably not that deep. It's probably like fairly superficial, right? It's based on, yeah, it's probably fairly superficial, and same with the teacher. Whereas like a human's understanding of what a teacher and student is like, you know, very, very rich, because probably most of us have been students ourselves. We know teachers is very, very rich. And this kind of links to what Thomas was saying, because like if we're thinking about what sort of permutations could we actually carry out on the student and the teacher, I mean, we kind of, as humans, we sort of know what permutations are possible within the class of like student, whereas a machine learning model, you know, basically probably doesn't know, because they don't really understand what a student and teacher is. So that is why there's a guy called Walid Saba who says all the information is not in the data. So like information about what a teacher actually is not in the training set for a computer vision model. Okay, so yeah, so the question is, can a machine model ever really like understand stuff? It can classify things based on probabilities, but can it actually ever understand? Does anyone put in the chat, like, does anyone have an idea how can we get around this problem of like, I mean, this is a huge, ridiculous question. Does anyone have a sort of idea about like what we could do to make machine learning models, you know, better at like actually understanding? You can put it in the chat. It's kind of a ridiculous question, to be honest. I like more data. Yeah, that's a great point, actually. I mean, I think that is like one of the approaches definitely that people are taking. Yeah, exactly. It's a really good point though. Like if we get to GPT like 700, maybe GPT 700 will just be like as intelligent as a human. Good point. Feed it daily news, so it's like it knows what's happening. Well, yeah, that's a really good point as well. So yeah, that's a good idea. That's a good idea. Embeddings. Yep, that is a good point. That is a good idea. I mean, to be clear, I don't actually know the answer, but I can tell you what some people think could be an answer is to have a sort of like hybrid of empirical and symbolic AI. So like, and actually, this is the company that I work for are trying to do this, as I think are like many other people, and it's yeah. So the idea is that you could actually combine empirical like machine learning with symbolic AI to some extent and have like a hybrid model. And it's not true to say that these people are actually trying to do like hybrid models, to be honest, but these are three quite important like deep learning kind of like researchers or like figureheads, I suppose, of the deep learning movement. And yeah, so and they also have like approaches that they're taking. So for example, Yoshia Bengio, he argues that deep learning has been really good at getting artificial intelligence to similar to the level of like animals. So in terms of like perception, deep learning, like in terms of like computer vision models, like they're up to the level of sort of like animal intelligence. But he argues that like deep learning hasn't really got to the level of what he calls system two thinking, which actually comes from a book called Thinking Fast and Slow by Daniel Kahneman and Amos Tversky. But basically, what he's saying is that like we don't have AI that can actually reason yet. It can't like reason about things. And so he argues that basically we need to have some sort of like high level variable that actually means something, and like recombine it in certain ways within like a sort of I'm going to say yeah a sort of like model to achieve this kind of like reasoning capacity. And then Jan LeCun has promoted the idea of embodied AI, which involves like multimodal data, so that like there can be a richer representation where you have like not just sort of like images, but other types of data that give like a fuller picture of what something is. And Jeff Hinton, I think this is actually kind of an old idea, but he had this idea of like capsule nets, which is an extension of like convolutional neural networks that has like some sort of hierarchical like knowledge within it. So these are some like approaches, but I would say if you're also really interested in this sort of thing, these kind of debates are often like these things are quite often debated on some podcasts. Like there's a podcast called Machine Learning Street Talk, and there's another one called TWML, and they're actually debated on these podcasts. So if you're interested, I would check these out. But otherwise, that is it. Does anyone have a question about that?